The first time I looked at a wiring diagram, all I could see was a bunch of wires going to components I didn't recognize. Boxes, symbols, numbers, lines going everywhere, and absolutely no idea what any of it meant. If that sounds familiar, this video is for you. By the end of this video, you are going to be able to look at a basic industrial wiring diagram and actually understand what you're seeing. You'll know what the most common components are, what the symbols mean, and how to follow a circuit from start to finish. Let's get into it. Welcome back to Panel Design Pro. Before we start reading one, let's make sure we understand what a wiring diagram actually is. A wiring diagram is a visual map of an electrical circuit. It shows every component in the circuit and exactly how they are connected together with wires. Think of it like a road map. The roads are the wires, the destinations are the components. And just like a road map, once you learn how to read it, you can navigate anywhere. There are two main types of diagrams you'll come across in industrial panel design. The first is a schematic diagram, sometimes called a ladder diagram. This shows the logical flow of the circuit. It doesn't show you where the components are physically located. It just shows how they connect electrically. This is the most common type you'll see in panel design. The second is a wiring diagram, which shows the physical connections and sometimes the actual location of components inside the panel. In this video, we're going to focus on the schematic, because once you can read a schematic, everything else becomes much easier. Here's the part that trips up most beginners: the symbols. Every component in a wiring diagram is represented by a symbol. Once you learn these symbols, the diagram starts to make sense immediately. Let's go through the most common ones. First, the power rails. On a ladder diagram, you'll see two vertical lines running down the left and right sides of the page. The left rail is your hot or positive supply, usually labeled L1 or plus 24 volts. The right rail is your neutral or negative return, labeled L2 or common. Every circuit rung connects between these two rails. Second, the normally open contact. This looks like two short vertical lines with a gap between them. It represents a switch or contact that is open at rest, meaning no current flows until something activates it. Third, the normally closed contact. This looks like two short vertical lines with a diagonal line through the gap. This contact is closed at rest. Current flows until something opens it. This is what your e-stop button uses. Fourth, the coil. This looks like a circle or parentheses symbol at the end of a rung. It represents an output, like a relay coil, a contactor, or an indicator light. When enough current flows through the rung, the coil energizes and does its job. Fifth, the motor symbol, usually shown as a circle with an M inside. This represents the motor or load being controlled. Now let's put it all together and actually read a circuit. I'm going to walk you through a very simple motor starter circuit, the most common circuit you'll see in industrial panel design. Here's what we have on screen. On the left rail, we have our 24-volt supply. On the right rail, we have our common return. The first thing in our circuit is a normally open start button. When nobody is pressing it, the circuit is open and nothing happens. Next in series, we have a normally closed stop button, your e-stop or stop push button. Remember Dobry Naniak. Normally closed means current is already flowing through it at rest. When you press the stop button, it opens and breaks the circuit. After that, we have an overload relay contact, another normally closed contact. This opens automatically if the motor draws too much current, protecting the motor from damage. At the end of the rung is our contactor coil, labeled M1. When current flows all the way through the rung, past the start button, past the stop button, past the overload, the coil energizes. When that coil energizes, it also closes a second contact in parallel with the start button, called a seal-in contact or holding contact. This keeps the circuit energized even after you let go of the start button. That's how a motor keeps running after you press start just once. This is the foundation of almost every control circuit you will ever work on. The last thing that confuses beginners on wiring diagrams is all the numbers and letters you see scattered around. Wire numbers are assigned to every wire in the diagram. They help you identify which wire is which when you're building or troubleshooting the panel. If wire number 103 leaves one component and connects to another, both ends of that wire are labeled 103. Follow the number and you follow the wire. Component tags are the labels on each device. Things like CR1, M1, PB1, OL1. These are reference designators. CR stands for control relay, M stands for motor contactor, PB stands for push button, OL stands for overload relay. Every component in the panel has a unique tag so you can find it on the diagram and in the physical panel. Once you understand wire numbers and component tags, a wiring diagram stops looking like chaos and starts looking like a very organized, logical map. Let's recap what you learned today. A wiring diagram is a map of an electrical circuit. Ladder diagrams have two power rails with circuit rungs between them. The most common symbols are normally open contacts, normally closed contacts, and coils. You follow a circuit left to right across each rung. Wire numbers and component tags help you identify every wire and device in the panel. That's the foundation of reading any industrial wiring diagram. With practice, this becomes second nature, and in future videos we're going to start building these diagrams ourselves in AutoCAD Electrical. If this video helped you, hit subscribe so you don't miss the next one. Next video, we're going to cover the most common components you'll find in a control panel and how to select the right ones for your application. I'll see you in the next one.